Welcome. My name is Okubo Benebo. The interlude during subsistence farming, obtaining between the end of planting and start of harvesting, is in fact a grace period to mentally reflect on the post-harvest context and the advantages and hardships that may arise from the context. After all, the farming operations is not expected to be a one-off operation, but rather an ongoing operation, and hence requires continuous improvement. And the looming post-harvest context is the sort of rinse-repeat circumstance that needs to be fully embraced to evaluate those operations of the key functions that require improvement of the underlying technology with improvement retrofit designs. In fact, the burner functionality augmentation design that improves over the existing burner is a result of such thinking about the underlying technologies, improvement design. The functionality augmentation happens to be based on the liquid fuel being fed to the electric burner generator biofuel burner in the liquid form and not as vapor. Then, of course, liquid alcohol of some form is expected to be produced from the bioprocessing of the farm post-harvest biotics. So then, better to design for that ahead of time, because the real plan has liquid flowing into the burner. The performance improvement design will terminate letting methanol vapor flow into the burner, but rather actually have the methanol liquid flow into the burner. As is currently operating, the methanol produced in the methanol bioreactor was allowed to heat up, evaporate, and then flow by natural convection of buoyancy into the burner on the presumption that methanol pectination produced exclusively methanol. Yet, because of the complexity of the mechanism of even simple reactions, this presumption may not be entirely tenable. At least the possibility exists, and the possibility must be taken into consideration in the decision to feed the methanol liquid directly into the burner. Correspondingly, the liquid biofuels of the post-harvest farm biotics are expected to be not even the binary water-methanol mixture projected for the methanol bioreactor when modified to have the same operating state of suspension bioreactor. The metabolism of the digester microorganisms is ordinarily accompanied with waste, which often is excreted by the microorganisms as in condensed matter, and as such dissolved in the liquid environment. These particles are actually bioorganic substances, the composition of which depends on the biotics and the digester bacteria. There are, however, always bacterial microorganisms that can metabolize the bioorganics into alcohols, although which alcohol obtains from the metabolism will again depend on the bacteria or microorganism that is fermenting the alcohol. So an improvement in anticipation of the post-harvest issue in alignment with the objects of development path for the farm is to change the methanol reactor operating method by setting the methanol liquid as the effluent stream and let it flow into a storage tank for future processing of a monoalcohol liquid for use in the burner. Of course, the processing of a mixture of liquids for separation into different components is a well-known separation process of distillation. In synopsis then, this episode entitled Subsistence Farms Power Generation Biofuel Resource provides a design for deployment in subsistence farms for the extraction of the liquid biofuel on which the design of the electric power generation base for operations without limitations to the specific liquid biofuel. The driver rationale guiding the processing of the biofuel liquid has the object of adoption of a separation process provisioning the design specifications liquid biofuel on which the design of the power generation burner is based for operations without limitations to the specific liquid biofuel. The significant point is that a specific type of alcohol can be produced by each farm that chooses to process the waste, and that the type of alcohol produced by each farm that chooses to process the waste will depend on the specific manner of processing and the microorganisms used. In fact, given the circumstances of the bioorganic utilization context in which the bioalcohol liquid is not a simple binary mixture of alcohol and water, the farmer would need to actually significantly dry up the alcohol, and the situation in which the alcohol product happens to be even a mixture of more than one type of bioalcohol, then a process of separating the mixture for the preferred alcohol would be necessary. So then, the farm's waste utilization context in which the bioalcohol liquid is not a simple binary mixture of alcohol and water, but say azeotropic, or even a mixture of more than one type of bioalcohol, will have the farmer need to actually significantly dry up the alcohol or perform separation of the alcohols respectively. So usually, in order to extract a particular alcohol from the mix, the bioalcohol vapors evaporating out of the reactor as a single stream is pumped into the process equipment known as cooler condenser, which is designed of a simple shell and tube structure. The vapor is pumped into the tube, and the cooling water is pumped through the outside in the shell jacket. The vapor condenses on the tube walls and flows downwards into a stream and on into a storage tank, providing a volume of bioalcohol for energy production, while the air in it flows up and out through the tube of the cooler condenser. Agreed, in industrial setting, the fuel vapor collected from the bioreactor following the collection would be recovered through a separation process, which the liquid is at least a binary liquid mixture. However, when there is a level of certainty that the liquid is mono or even dominantly alcohol, the use of the cooler condenser process may be just good enough for objects of the project. However, the separation of multiple alcohol liquid mixture as may be applied to the methanol liquid product may be performed in a variety of ways, but primarily two ways: fractionation process system, a fractionation separation process more commonly called distillation in industrial processes, or a sequential batch separation process, although this process requires knowledge of the number of alcohols in the mixture ahead of the design. Yet, ordinarily in industrial settings, the fuel vapor collected as the liquid product from the cooler condenser is stored and a sample taken to a chemical analysis lab to analyze the alcohol contents of the mixture. However, in this case of post-harvest retrofit engineering, that is not possible. Therefore, the development of a small fractionation process system, which is more adaptive, is the appropriate upgrade to be retrofit engineered into the existing operations towards achieving the object of using the liquid biofuel that should obtain consequent on the processing of the post-harvest waste. So then, the methanol pectinase reaction product of liquid fractionation is more operational improvement design as soon summarized. Continuing with the upgrade improvement design of the methanol production is premised on the subsumption that the methanol bioreaction had been assumed to be occurring with a specificity that does not allow byproduct alcohols, but that may not be correct after all, and hence the decision to design for the upgrade anyway. By the sequential batch separation process, the separation of the bioalcohols is achieved with the use of series of flash equilibrium seals. An equilibrium seal is a vessel of low relative pressure into which the liquid alcohol is flash aspirated, resulting in the relatively more alcohol being vaporized and piped out of the vessel, while the less volatile ones, including any water, remain as liquid droplets and fall into the vessel, where by continual coalescence collect into a liquid bulk. The vapor stream is then pumped into a full condenser which has the same structure as the cooler condenser, but without air, and being smaller tube, causes the complete condensation of the vapor. The flow of the vapor and the coolant may be concurrent or co-current. The choice only mostly affects the length. So, for all intents and purposes in this case, it's not very relevant except for cost. Then the process is repeated again in the next equilibrium still, where the liquid is pumped at high pressure and throttled into the still, which is at low pressure, causing yet again vaporization of the more volatile alcohol and the rest settling as liquid in the vessel, only to be pumped to the next. Usually the number of equilibrium stills equals the number of alcohols in the liquid mixture. Yet there is also no inhibiting factor that should prevent a farmer from using a combination of both cooler condensers and equilibrium still distillations in any arrangement as is determined to be efficacious to the objects of the production. In fact, for those cases where the bioalcohol is a mixture of alcohols and the farmer desires to separate into bioalcohol types, then the equilibrium distillation vessel may even be deployed in series but operated according to some tuning of the process parameters that allows only one bioalcohol to vaporize in each vessel and get piped out. In a fractionation process system design, a minimalist positing has the fractionation process consisting of a kettle and a fractionation column, together with, pumps and assortments of fluid devices, sensors, and instruments. Of core here are the kettle and the fractionation column. The kettle is usually of the form of a horizontal drum lying on its side on a heat source, providing enough heat load to cause the liquid inside the drum to boil, and the liquid inside in this case being the alcohols mixture. The kettle boils the alcohol and sends the vapor into the fractionating column. Usually the fractionation column is a pipe of some certain diameter capped at the top and bottom, and along the height in the upward direction along the column, stages are set marking the extraction points, which are based on the boiling point of the alcohol of the mixture as determined from the chemical analysis. The corresponding outlet ports are made slightly above the stages, and condensers are fixed to those ports. The outer jackets of the condensers have cold water flowing through, while the inner tube has the target alcohol vapor flowing through upwards. Invariably, the alcohol vapor condenses completely and the liquid droplets on the wall falls back down to collection tanks. Some of the liquid also settles on the stage and the vapor bubbles through, and in the process some condenses to create an equilibrium state that enables the separation. Clearly, as of this point, the conclusion that could be drawn is that the actions taken so far have enabled the farm to produce biofuel which can be used in any design-specific combustion technology, coupled with an energy transducer to provide power, both mechanical and electrical, with the choice of the final thrust left completely at the disposition of the farmer. The design and fabrication of the various process equipment adopted throughout the presentation are quite challenging, but can be realized even in rural communities with the skill set of a blacksmith working in consultation with an engineer or two. Although, on the other hand, in a fairly developed society, the performing of the same task would be undertaken through a machine shop by a machinist also working in consultation with an engineer or two. Worthy of note is that the choice of the use of suspension homogeneous bioreactor also brings about an issue that must be contended with. Though the biotic waste may have been fully recovered by the end of the process, a waste mush consisting of the dead fermenting microorganisms will obtain and will have to be disposed of. Even so, a well-known situation is that this residual waste can generally be eliminated with the use of heterogeneous suspension fermentation process. The pumps of the water delivery and dispensing systems also now stand to be powered from the would-be derivative power, and remarkably without being obtained from use of fossil fuel resources, and indeed positioning the operation to transform subsistence farming into green subsistence farming. And it is a wrap. On that note, I say to you, thank you so much for coming to listen to this observation about efforts aimed at alleviating world hunger through subsistence farming by both urban dweller farmers and emergent country small farm farmers. You are truly appreciated, and if you would like to get privileged viewer reader information, access podcasts of specialized contents, or access even vertically integrated concepts, then I implore you to join my supporter club and enjoy that privilege status. Moreover, while still here, do please take a moment and subscribe to the channel as to be informed of the publication of every new episode as soon as it is released. Thank you. Bye. Till next episode.